Hello students, it's Dr. Shragi, and I want to talk to you today about a term that we probably have actually slipped up and discussed a few times, mentioned without actually giving you a good definition for before in the past, and that is this term that you're going to see in your textbook and in my lectures called air parcels. Parcel as in like a package, okay, a package that you'd get in the mail or something like that, hence the corny PowerPoint background that you're seeing on here. And I get it that the term air parcel is a confusing term. We use this word air parcel, and I know from many years of teaching experience that students will often think I'm saying air particle. Okay, an air particle, that's not really a thing. That's not a term that we're going to use. Or they're going to say, oh, an air molecule. Air molecules are different from air parcels, as we're going to see. And another term that comes to us from like weather and forecasting and so on is air mass. Air mass is something we're going to be seeing throughout the semester. That again is something different, and I don't want to get that turned around as to what we're doing here. Now, if you actually go and get the Glossary of Meteorology, the big book that atmospheric science majors all get, or there's a great website that gives all the definitions and so on, you get this rather technical definition as to what constitutes an air parcel. And it has the right idea, the good ideas that I want you to understand buried in this technical definition. So let's kind of take it apart and see if we can figure out what an air parcel is. And I'll be highlighting parts of that definition in red as we go along. So the first thing I want you to understand about an air parcel is what it says here about an air parcel is an imaginary volume of air. It isn't like I can show you an air parcel, like, oh look, here I have an air parcel in this bubble, or in this bottle, or look, an air parcel. No, it's an idea. It's an idea that we're going to be using to try to solve problems. It's an imaginary volume of air, and I can do things. I can move it, I can put forces on it, I can change its temperature, whatever. In fact, if I highlight the next part of the definition of being an air parcel, you'll see that one of the things that makes it an air parcel is that it may be assigned any or all of the basic dynamic and thermodynamic properties of atmospheric air. In other words, we can go ahead and say, here's my air parcel, and let's say its temperature is 20 degrees Celsius. Or let's say that its pressure is this much. Or let's say that it is this high above the ground, or that there's this much force acting on it, or whatever. It's just a way of making problems. Okay, of trying to take apart ideas and apply them to just a little volume of air. The question is, how big is an air parcel? How big of an air volume are we talking about? Well, an air parcel has to be large enough so that it has, as the Glossary of Meteorology definition says, a very great number of molecules. Well, it turns out that's not all that hard. I mean, as long as you're talking about a volume of air, even a centimeter by a centimeter, I mean, there's going to be trillions and trillions of molecules involved in that. So, and getting a very large number of molecules, that in and of itself is not so problem as long as we're not talking about like a microscopic volume of air. But to continue with the next part of the definition here in red, it has to be small enough so that the properties that you assign to it are approximately uniform within it. What do we mean by that? Your air parcel is going to have a pressure. This volume of air that I'm talking about is my air parcel. I'm going to do things with it. It has a pressure. I don't want it to be a big enough air parcel that like I have to worry about, well, the bottom of the air parcel has a higher pressure than the top of the air parcel does. No, that's just going to make things bad. The air parcel has a pressure. Or the temperature. I don't want the north side of my air parcel to be a different temperature than the south side of my air parcel. I want to be able to say, hey, my air parcel has a temperature of 20 degrees Celsius, or something like that, okay? I don't want it to be big enough that I have to worry about the fact that it might be different temperatures at different places, or different pressure, or different humidity, or a different wind speed, or anything like that. So, as the Glossary of Meteorology's definition gives you there in red, a cubic foot of air could fit within most contexts when we're talking about what we mean when we talk about an air parcel. You have to have enough air molecules that it's very large number, and things like pressure and so on mean something, but you don't necessarily, there are these very large number of molecules hitting the surface and so on. You need to have enough air molecules moving around that you can talk about temperature and so on. You need millions and billions and trillions of air molecules, but you don't need something, the size of a state or something like that to call it an air parcel. When we address air parcels, like in the context of this course and similar courses, we always will say that the air parcel will have the same pressure as the air around it. I actually have inset there a little slide that we'll be seeing later in the semester where we'll be talking about the temperature changes and so on that happen as we move air around. But see how I have a little air parcel, is that blue circle down there by the barn, and then I lifted it, and as I lifted it and it was coming across air that was at a different pressure than the air around it, my air parcel will just expand until it is the pressure of the air around it. So we'll never have a situation where air parcels have one pressure, the air around them have a different pressure. If they did, they'll just expand or contract until they have the same pressure as the air around it. That in and of itself is not really a problem. So when I'm taking an air parcel and I'm moving it around, you'll always know that it has the same pressure as whatever air is around it. And like I said before, you want to make sure that the air parcel that you're talking about is small enough that it has a temperature. Not like its north side has one temperature and its south side has another. Or its top has one pressure and its bottom has another. We want it to be small enough that we can neglect anything like that. So, you don't want its north side to be cold and its south side to be warm or something like that. And like your book said, a good way to think about an air parcel is like maybe a cubic foot of air, or a balloon, or a beach ball of air, or something like that, or whatever. But I mean, it's just a small volume here. In general, other than the pressure though, we aren't going to say that these air parcels necessarily have to have the same anything else as the air around them. So like maybe my air parcel will be warmer than the environmental air around it. That's a good vocabulary word to know. The air around our air parcel is called the environment. So maybe our air parcel is warmer than the environment, and we'll figure out then why the air parcels rise. Or maybe the air parcel has a different humidity than the air around it, and we'll think about what that means, and so on. In general, it won't necessarily have the same properties as the air around it, the environment, except it will have the same pressure as the air around it. Another weird thing about air parcels is that for this idea to work, we're going to assume that our air parcel does not mix with that environmental air that's around it. When I take my warm air in my warm air parcel, we're not going to think about the fact, well, maybe that warm air inside the air parcel will just mix with the cooler air in the environment around it. No. I mean, in the real world, that probably would happen, but for the kinds of problems we're going to be doing using air parcels, we're not going to worry about things like that. Okay? That process actually is called entrainment. Well, you'll learn more about entrainment later in the semester, but entrainment is this idea that air parcels can mix with the environment and so on. For the time being, we're going to say that our air parcels do not mix with the environment around them. Okay, I guess I can think of this as being a useful tool. I want you to be clear though, air parcels are not the same thing as an air molecule. A molecule cannot be an air parcel. A single air molecule, or even just a very small number of air molecules, doesn't really have a pressure. Terms like pressure and temperature don't come from one molecule. That's a property of a group, an ensemble of molecules. It takes millions of molecules for ideas like pressure and temperature to have physical meaning. Even like a small number of molecules, like what I have here in this bubble or whatever that we have here. I like how it's labeled air parcel. I found this image someplace on a Google image search. But I mean, that would not be enough molecules to have an air molecule. I don't know, what is there, maybe 50 of them there or something like that? That's not an air parcel. Air parcels are maybe a cubic meter or something, or a cubic foot or something like that. And they need to have trillions and trillions and trillions of molecules to have a meaningful pressure, a meaningful temperature, etc. A term, though, that I warned you at the beginning of the lecture here, air mass, that's something different too. These like blue and green and purple areas that I have labeled on here are examples of air masses. They're these giant volumes of air, maybe about the size of like states or even countries or something like that. When a cold air mass comes in the winter and it gets bitterly cold, a warm air mass in the summer coming up from the south and the temperatures get high and the air gets really muggy. Well, these are huge. They're extend 1,000 kilometers in each direction. Clearly, they're not the same temperature and the same pressure and the same humidity everywhere inside of this air mass. So an air mass, that's a thing, but that's not the same thing as an air parcel. Okay? An air parcel is going to be used for solving certain kinds of problems in our class. Are air parcels real? Well, no, actually. Atmospheric science majors always find that shocking. They always want to say, wait a minute, this is a real thing, right? We're really moving. No, in fact, the atmosphere is not made up of like little bubbles of air that we're going to move around, and they aren't going to mix with each other, and they're going to necessarily have a different temperature than the air around them, and so on. This is just an idea. But it's a darn useful idea. Even though the atmosphere isn't made of air parcels, and they're just an idea, it turns out that they're a useful idea because a lot of things that happen in the atmosphere happen where the atmosphere is acting as if it were made of air parcels. When we learn about things like thunderstorms or turbulence or whatever, well, the atmosphere is not really made of air parcels, but in fact how an air parcel would be moving is exactly how the real atmosphere is moving. So it's a useful tool, it's a brilliant simplification to help us understand thunderstorms, turbulence, lots of phenomena over the course of the semester. And it doesn't matter that it's not entirely real. There's actually a number of these kinds of ideas in atmospheric science and science in general, where we can kind of approximate the real behavior with some much simpler idea. In this case, we're going to approximate the real behavior of the atmosphere with this idea that it's made up of these bubbles of air moving through the atmosphere. Alright, it's a powerful tool. We'll be shedding light on that idea many times throughout the course of the semester. Before we go forward anymore, though, I do want to ask you a couple quick questions about what air parcels are. Question 1. The pressure of an air parcel is always the same as the pressure of the air around it. True or false? Make a choice from your two options and get a little feedback before you move on to question 2.